Hello everyone, this is the lecture number 4 for engineering economy. In the last class, we have learned the cost concepts, and some design economics. So those common languages we're going to use in this class. And today, the class is going to be very, calculation heavy. Okay, and today's class is very important because we're going to go over step by step an important example in this chapter. And this example is gonna be appear in either your homework or the test or exam. So please pay attention to this video, okay? So before we jump into that example and functions, let's just review what we have learned so far. So chapter 2 is all about cost, right? And we have learned so many different types of costs. We know the definition of cost, and we know fixed costs and variable costs, and we know the difference between them. Marginal costs and average costs. How do you calculate them? Okay, and we understand sunk costs and opportunity costs, and also we know the difference between recurring costs and non-recurring costs. The last pair is the direct costs and indirect costs. Remember that we have practiced together an exercise, right, about the definitions of all the different types of costs. So if you are still not familiar with these definitions, please go review that video. I think that's the video in the last class, okay? To review how did we solve those, definition problems. And then we have learned these important languages, right? The terms we're going to use in this subject. And also very important is the price, the demand, revenue, cost, and profit. Those are the 5 concepts we need to understand. Second, we need to know how to calculate. Okay, and the whole subject of engineering economics is all around this 5 concepts. Okay, so here are the definition of these concepts. So price is very easy to understand. You buy something, you pay at the price, right? So price is how much you sell or how much you pay for a unit of product. And price usually will reflect the value of something, okay? And demand is how many units of a product you sell, okay? And or how many units you consume on the market per day, per month, or per year. There is a time frame to accumulate this demand, right? Okay, then third, the revenue. So revenue is just the total income generated by selling something. Okay, you can sell goods, you can sell services. But revenue is just the total income. It covers everything. So revenue is not the money you actually earn because you need to account for the costs and other expenses. Okay, so what you really earn in your pocket is called profit. And profit is what you are chasing for. Okay, so you might hear that a company is non-profit, okay, or a company is profit chasing company. We have never heard something like a non-revenue company, right? So profit is really the goal of a company, of running a business. You want a profit, you want it to be bigger than zero so that you're making money. You want it to be bigger and bigger. You want to maximize your profit. Okay, so profit is the true goal. But revenue is just the income we will calculate first. Okay, so because you know how much price you sell one product, and you also know how many products you sell. So based on these two variables, you can easily calculate the revenue. But to really know the profit, you need to consider the costs as well. We will talk about it later, okay? So we learned two functions in the last class. It's about the cost, okay? So we learned that total cost, CT, C is cost, T is total. So total cost is the sum of CF, the fixed cost, total fixed cost, and the C capital V, the total variable cost. Okay, this is easy to understand. Okay, and then usually what is given in the problem or what is given in the real case is easily you can get the variable cost per unit. Okay, so usually you don't get the total variable cost at the beginning. You get the variable cost per unit, which is C lowercase v. Okay, and how do you calculate the total variable cost then? That's the function number 2. Okay, so you're going to use the C lowercase v, which is the variable cost per unit, times the number of units you sell or you consume, which is demand. So demand is written in D. That's the symbol for demand. Okay, so these are the two functions we have learned, and we have seen this example to let you practice the functions. So that's what we have learned in the last class, and today we're going to learn more about those 5 different things: price, demand, revenue, profit, and the cost. Okay, we're going to learn more functions to calculate each one of them. Okay, so this is something new: price and demand relationship. So think about that. Price is how much you sell a product, and demand is how much are consumed, how much are bought in the market. Okay, so the first thing about demand and price is demand D changes according to the price P. Okay, this is easy to understand. Think about selling your bread. We're still running a bread shop here, okay? Selling a bread. So if your bread, one piece of a bread is cheaper, right? Then maybe there are more customers to buy it because it's cheaper. But of course, you have to maintain the quality. That's the assumption. So under the same quality, if your price is cheaper to sell a bread, then you're going to sell more breads per day or per month, right? That's very easy to understand. So the demand on the market, how many breads are sold, how many breads are bought by customers, that demand is changing according to the price. Okay. And then think about this question. If a product sells at a higher price, then fewer or more people will buy it. Okay, so if you're selling at a higher price, do you think more people will buy it or fewer? I think it's fewer. Because it's more expensive, then people wouldn't spend that much at the same product. They might choose another cheaper one, right? So the demand is going to be lower. And second, if a product sells at a lower price, then do you think more or fewer people will buy it? If it's cheaper with the same quality, of course more people will buy it, right? So these two situations are very easy to understand. We see it every day on the market. So now what conclusion we can get is the relationship between price and demand. Here is the relationship, which is very important, okay? So I'll give it a star. If price increases, demand will decrease, right? So if you sell it more expensive at a higher price, the P increases, right? So fewer people will buy it, which means there will be lower demand. And then if price decreases, it's cheaper, something is cheaper, then demand will increase. That's very easy to understand. If it's cheaper, more people buy it and more you sell, right? So demand will increase. Well, this is the conclusion of the relationship between price and demand. So what if you sketch the relationship using an X and Y coordinate system? You put it on the X and Y chart, okay? So you use X-axis as demand D, and you use the Y-axis as price P. Just imagine what kind of line you end up with. Okay, so this is gonna be the line. Is it the same as what you think? So let's say the D is the X-axis, that's the demand, and the Y-axis is price P. Okay, so what we just use our common sense, like if the price is higher, right, like this point, maybe the price is 1,000, then you get this demand, like that's the number of breads you sell or number of products you sell. Maybe that number is 20, okay, 20 units of product. And if we also know if the price is cheaper, like somewhere here, the price might be just 200 US dollars, and then of course you will get more demand, okay, you sell more, maybe that number will be 100, okay, so you end up with a line going down, okay, not going up, it's going down, which means when price increase, demand decrease, right? And when price decrease, demand increases. That's what the line going down tells you. And then if you want to write the function of this line, this is gonna be the function you can use. So this function or this formula, it describes a line like this. So P is the price, and A and B are just two constant, okay, and the D is demand. Okay, so for different types of products, you're going to have different types of this type of line, but they're all going downward. And the difference is they have different A and different B's to describe the detailed relationship. But all of them can be written as this abstract form. Okay, so maybe you think this is too abstract, but let's just take a look at a real example. Okay, so keep this in mind. Our relationship between price and demand is always a line going down, and a general formula for this relationship is written as P equals to A minus BD. okay? And depends on different types of products. The A and the B could be different, okay? P is just a dependent variable, okay? And the D is independent variable. Okay, now the example, what it said. It says a company produces an electronic timing switch that is used in consumer and the commercial products. Okay, so they are producing electronic timing switch. That's the product. And the fixed cost, CF, is $73,000 per month. Okay, that's one variable. And the variable cost, C lowercase v. Look at this. This is lowercase v, which means it's a variable cost per unit, right? It's 83 per unit. Okay, that's another variable. The selling price per unit is written as P equals to $180 minus 0.02 times D. Okay, so that's the relationship between P and D. Okay, so based on this equation, what values you can get or what conditions you can get. Okay, so first, in this statement, we already know that CF is what? Is 73,000 per month. So every month your fixed cost is 73 grams. And you also know C lowercase v is $83 per unit. Okay, so this is the second variable or condition you can have. And the third thing is it tells you that for selling the electronic timing switch, this type of product, a specific relationship between P and D is 180 minus 0.02 times D. Okay, so what I want you to do here is compare these two formulas. Okay, compare these two formulas. So P is P, right? And D is D. That's the two same identical variables. Okay, now can you tell me what is A and what is B? Just compare these two formulas, okay? So P equals to A minus BD, and the specific relationship given is P equals to 180 minus 0.02D. So seems like this 180 is A. Okay, and this 0.02 is B. Do you think so? If you compare these two, right? Because we said that the P is A minus BD is a general form. And for different types of products, you're going to have different A and different B. to describe the specific relationship between P and D, right? Which means for a specific product, you're going to have A as a number, B as a number. And how do you know what number it is? This is how you know that. You compare the general formula and you to the specific formula you're given. Okay, so what you can write here is A is 180 and B is 0.02. Be careful. There's no minus, no negative symbol, no negative sign before the 0.02. B is a positive number, okay? Don't include the negative sign. Don't include this negative sign. Okay, don't include that. Do not include this negative sign in the value of B. So B is a positive number. Okay, this is very important. A lot of students struggle with this. Okay, so your B is gonna be a positive number. Please do not include that negative sign before it. Okay? All right, next is about the revenue. Remember that the revenue is determined by how much you sell for a product and how many products you sell. Okay, the price and the demand. That's very easy to understand, right? If you sell your bread at $5 each and you sell 100 bread per day, you're going to revenue income equals to what? To 100 times $5, which is $500 per day. That's your income. That's your revenue. Easy. So total revenue so if D is demand, right? Number of units sold. If P is the price per unit, your total revenue is what? Is P times D, price times demand, right? How much times how many? And here is an example. So given the price for one piece of bread is $5 per bread. $5 per bread, that's the price. And you sell 100 pieces per day. 100 pieces per day, that's your demand. What is the total revenue per day? And what is the total revenue for a month? Okay, let's do the total revenue per day because you know your demand per day is 100. So total revenue per day is gonna be, you can write it as TR, right? It's gonna be what? Based on this function, it's P times D, right? So P is $5 per bread. D is 100 pieces. Of course, you don't have to write the units like what I do here, okay? You can just write it as 5 times 100, which is fine. So that's gonna be 5 times 100, which is what? Which is $500 per day. Okay? And what about the total revenue per month? Total revenue per month and the assumption is 1 month equals 30 days. So if you know like your revenue is $500 per day for 30 days, how much is it? Just use the 500 per day times 30 days. So it's gonna be $15,000 per month. Okay, so this example is just to show you how do you use this function. Okay, so if we say this is number 1, number 2, and then this function might be called number 3. Okay, and here we want to step further to learn about the total revenue function. So we have already seen this. Total revenue is P times D, right? Price times demand. And what if we replace the P by P is A minus BD? Remember that? That's the line for the price and demand. And we say the general formula is P is A minus BD, right? So what if we replace the P by this formula? Then you can write the total revenue in another way. Okay, let's see. So total revenue is P times D, that's true. And if we replace P by A minus BD, okay, so we can have A minus BD, so that's P, right? Times D. So nothing changed. We just replace the P by something in A minus BD, right? And if you open this bracket or parenthesis, what you have is A times D minus B times D squared. Okay, so which means if you already know from a given condition that what is A and what is B and what is D, you can calculate it. You can calculate your total revenue based on these values. Okay, so that's why we want to rewrite it in this form. For example, in this case, we know that A is 180 and B is 0.02. So if we also know a demand D, the number for that, we can easily calculate the total revenue. Okay, in case you are very interested in the revenue, that's the number you can have. That's the way you calculate it. All right, so if we have this, okay, go back to this slide. So this is the function between total revenue and the demand. Okay, because A and B are just the constants. And so if you put this on the X and Y coordinate system, what kind of line could you have? Because this is a square of D, so it's not gonna be a straight line. It's gonna be a curve, right? So this is the line you can have. That's the line describing the relationship between demand and total revenue. Okay, so it tells you what? It tells you at the beginning, if your demand is really small, your total revenue is also very small. Okay, maybe your demand is 5 and your total revenue maybe it's just like 50. And once your demand goes up, okay, goes to this direction, okay, let's see, your demand is higher, more people buy your products, okay, maybe you hit the point demand at 35, and then because you sell more, you're going to have more total revenue. That's very easy to understand, right? You sell more, you got more income, and then your total revenue could be much higher than $50. If this is 50, then this height might be maybe 500. Okay, and of course, if you sell more and more, you have more demand, you can hit the point where you have the total revenue maximized. Okay, so that's the point you have your total revenue maximized. Okay, and that's some point we are very interested in. We want to know what is our extreme point. What is the maximum total revenue we can get? As a businessman, you always want to know that. Okay, so this is the function or formula. You can calculate your maximum revenue, total revenue. And these are just the process in between. You don't have to understand that. But here is what you're going to use. Okay, that's to tell you based on the value of A and B, this A and this B is in this relationship. Okay, so you always want to know for a specific type of products, what is the relationship between P and D, price and demand. And based on that, you can know the constants A and B, the values of them, and then you replace the value in this start function so that you can calculate the maximum total revenue. Make sense? And also we're interested in the demand, at what demand you can reach the maximum total revenue. And that demand, we have a name for it. We call it D hat. So this symbol above the D, like opposite V, it's called D hat. Okay, like a V upside down. So the D hat is the demand where you can get your maximum total revenue. And to calculate the D hat, you have this function A over 2B. Still, whenever you know what is A, what is B, you can calculate the D hat very easily. Okay, and somebody might be interested in why after the D hat in this area, why whenever we sell more, our total revenue becomes smaller, not even higher, right? Why the line is going down like this? Why don't we just sell more and more and more? Because the total revenue will decrease after the maximum total revenue point. But why? Why do we have this? Right? So one reason for that is, think about that. If you sell more, do you remember the relationship between the price and demand? You sell more means one possibility is you sell it cheaper, right? That's when you have more demand. You sell something cheaper, and once you sell it too cheap, your income will decrease because your cost doesn't change, but your price is cheaper and cheaper. Then your revenue will decrease, okay, because it's cheaper. So that's one possibility, that we have lower total revenue if we sell even more than the D hat. Okay, now let's talk about the profit. Very important. Profit is our goal, okay, is what we want. And the profit, we know it's total revenue minus total cost. Okay, this is a general function or formula, easy to understand. We said revenue covers everything, and revenue is not our true goal. We always want to consider the cost, okay? So revenue minus cost is gonna be the profit, what we have left in our pocket. And let's put the profit on the chart. Then you will get the point very easily. Okay, so the first chart we have here is the line of the revenue, right? That's the line between revenue and the demand, and we say it's a curve, okay? And we have a maximum total revenue here, okay? And to reach that point, we want to sell the demand at D hat, right? That's all we know. And also we know the cost. The chart number 2 is the cost, right? So we said we have fixed the cost as a flat line because it doesn't change along with how many units you sell. And we have variable cost, which changes along with the units you sell or you produce. And then the sum of them is the total cost. That's the line. Okay, so this is gonna be the line for the total cost for a specific demand. Okay, so if you want to know the profit, you're going to overlay these two charts together. This is the chart for total profit. Okay, let's see. So the curve is the total revenue, right? That's the curve. And then this straight line is total cost. So under any demand, let's see, this is a demand we want to take a look. Under this demand, maybe it's D0, okay? This is the total revenue, TR0. And this is your total cost. CT0. And what is the profit? We say the difference between these two is the profit, right? So this height is gonna be your profit. That's what we labeled out here as well. So at this point, D star, we haven't explained what D star is, but at D star, that's a specific demand. Under this demand, this is your profit, this is your this is your revenue, this is your cost, okay? And the difference between the revenue and the cost is profit. Cool? So the gray area, you see the interesting thing? The gray area from this to this point are where you have profit bigger than 0, because the total revenue line is above your cost line. Okay, which means revenue is higher than the cost. But out of this gray area, like here, if you're looking at the D here, maybe this D3, your cost is higher than your revenue. Wow, so you cost more than your income, which means your profit is a negative number. You're losing money, right? And the same thing happened to this side. If you're looking at a very high demand, like a D4, okay, your cost is this, and your revenue is here. Okay, so cost 4 and revenue 4. Your cost is higher, much higher than your revenue, which means you're losing money. Okay, so that's not what you want. You only want to stay in the gray area where you're making profit. Your profit is bigger than 0. Your revenue is higher than your cost, no matter at what demand, within this gray area. Interesting, right? Okay, so we know that there is a range of D1 prime and D2 prime. Between these 2 points, you are going to be within the gray area, okay? Because this is, so D1 prime D1 prime and D2 prime, okay, are where you have your profit, you have your revenue equals to your cost. Look at that, because at this point, your revenue and your cost intersects, okay? So that's where your revenue equals to your cost. And same here. Revenue equals to your cost because they are intersecting with each other. And the revenue equals to your cost, that's a phenomenon we call break even. Okay, that's we call, no, that's not what we call break even, that's what we call even, right? Because it's even. What your income equals to your cost, it's even. And the area in between, the gray area, okay, so this area, we call it break even, because that's where you break the even case. You have higher profit, you have higher revenue, you have positive profit, okay? And the D1 prime and D2 prime, they also have name. They're called break-even points or demands. Break-even demands, okay? So when we say break-even demands, it's a range. It's a range between D prime, D1 prime, and D2 prime. It's the range of this gray area, okay? It's a range of the demand where you can make profit, where your profit is bigger than zero. So break-even points or break-even demands is very important. You want to just keep your demand within that range, okay? And another important thing is look at this gray area. So for specific demand, like this demand, the length of this blue line is your profit, right? And if you have a higher demand, you're going to have this blue line, right? And this line, second line is longer than the first line, which means your profit is bigger than the first case. And then the line is longer and longer, which means your profit is bigger and bigger. And then at some point here, the line reaches its longest length. Okay, so here is our maximum profit, like this label. Our maximum profit, which is super important for every businessman. You always want to maximize your profit, and this is when you make your profit maximized. Remember that, okay? So you're going to have the longest profit line in the gray area at this point. What is the point? That's the demand you want to know, the D star. Okay, so D star is also called optimal demand. Because that's where you have your optimal case. You have the biggest profit you can make. Okay, so at D star, you have your maximum profit. Okay, so this is also very important to you. So what's the takeaways from this chart? First thing, you can only make profit between D1 prime and D2 prime, between the range of break-even points. That's the gray area, okay? Outside of that area, you're losing money. That's the first thing. Second, you can have a point, you can have a demand called optimal demand. At this demand, you're going to make your profit maximized. Okay, that's number 2. Number 3, the D star is different from D hat. Do you still remember the D hat? D hat is where you have the maximum revenue. Okay? So if you look down at the demand, where you have the maximum revenue, that is the D hat. So D star is different from D hat. And the maximum total profit is different from maximum total revenue. Okay, so 3 takeaways. I hope you can pause at this slide and then look at this chart and then try to figure out like the 3 takeaways I pointed out. Okay, first, what is the gray area? Why do you only make profit within that area, not outside? And what do you call the range? It's break even. It's break even demands, the range of the break even demands. Okay. And second, where do you have the maximum profit? And what's the demand called when you have the maximum profit? It's D star, optimal demand. And 3, where do you have the total revenue maximized? And what's the demand called for that, to have that total revenue maximized? It's D hat. And also the difference between D star and D hat. The difference between the maximum profit and the maximum revenue. These are the things you want to figure out by yourself. Okay? Pause at this slide as long as possible, as long as you want, and think through all of this. Alright, so after we have seen this chart, we already know that we can maximize our profit. And we can also know what is the optimal demand to maximize it. And we also are interested in the break-even points, D1 prime and D2 prime, right? So what function or what formula can we use? So first, the profit. The profit is total revenue minus total cost. That's very easy to understand. But to calculate, we need to write it into a formula, right? So what is TR? The total revenue, did you remember that? We have written it as AD minus BD squared, right? So the total revenue is AD minus BD squared. And what is the total cost? Total cost is CF plus C lowercase v times D. Right? Nothing new. Just the old formulas, right? And so this is total revenue and this is total cost. Okay? And if you open the parentheses and you merge the same terms, you can have this formula. So minus BD squared plus A minus CV times D minus CF. That's the formula you're going to use to calculate the profit. But to calculate the profit, what you need to know is what is A, what is B, what is C lowercase v, what is D, and what is CF. Okay? And another formula you want to know is the optimal demand. D star. Where is the demand you can reach your maximized profit? So D star is A minus CV lowercase v, okay, over 2B. So whenever you know the A, the B, the C lowercase v, you can calculate your D star. you can calculate, okay, what is the demand to maximize the profit. And in case you want to know maximize the profit, you just, what do? You replace the D with the D star in this first function. Then you can calculate your maximized profit. Okay? And the next formula is to calculate the D prime. D prime is D1 prime and D2 prime. Okay? You use this long function. Well, it is pretty long, but you don't have to remember that. You just use this function. We are open book, open notes when we do exams. So don't worry if you don't remember that, but you have to know how to use it. So here we have something interesting. We have plus minus. What does it mean? Okay, it means actually this is two formulas. Okay, so one formula is for D1 prime, which is because it's too long, so they want to write it in one formula. But actually, when you calculate, you need to do it separately. Okay, so D1 prime is minus A minus CV plus A minus C lowercase v square minus 4 times minus B times minus CF to the power of 1 over 2. The power of 1 over 2 means it's a square root, okay? And the whole thing, you want to divide the whole thing by 2 minus B. That's D1 prime. And what is D2 prime? So D2 prime is minus A minus CV. Now it's not plus, it's subtract. A minus CV squared minus 4 times minus B times minus CF to the power of 1 over 2 over 2 minus B. So actually, this single function or formula can be divided into this one and this one for the D1 prime and D2 prime. And whenever you got the value of D1 prime and D2 prime, you can put it as a range, okay? So D1 prime, D2 prime, that's the range. Range of profit, right? And we also call this to break-even points. You see, it's plural form, which means we got 2 points. Okay. All right. Now we have learned all the functions and formulas, and then what? So imagine that we have we know how to calculate the cost. How do we define, how do we decide which design method or which solution we go with when we want to make a decision, okay? So when do you want to use, we have a method called cost-driven design optimization. That's one method we can use to make decisions. And when could you use it? When revenues are not present or are constant among all alternatives. So your revenues are all the same for all options. We said we only focus on the differences. So if revenues are all the same, then we only focus on the costs because only costs are going to be different, right? So now we consider only costs. And how do we consider that? First, we always want to have the minimized cost. Okay, so between different options, which one costs the least? The least, that is the option we want to go with. Principle 2, select alternative with the least cost. Yeah, that's just what I said. So we want to minimize the cost. We want to select the one with the least cost. But it all depends on the fact that you already calculate the cost for each option. Okay, now let's do this example together. This is a very important example, okay? So you need to understand every step. This is actually the same example we have seen before, okay? So this company produces an electronic timing switch that is used in consumer and commercial products. So this electronic timing switch, that's something you want to sell. The fixed cost SCF is $73,000 per month, okay? And the variable cost C lowercase v, it's lowercase v, okay, is 83 per unit. The selling price per unit is P equals to $180 minus 0.02D. Okay, think about that. What is A? What is B? Okay, based on this situation, these are the questions you need to answer. So first, if we write P as P is A minus BD, we have seen this, right? Then what is the value of A and what is the value of B? Question number 2, what is the value of CF and what is the value of C lowercase v? And question C, determine the maximum total revenue, okay? And the question D, find the demand or volume at which the maximum total revenue occurs. That's the D hat. Question E, find the optimal volume or optimal demand at which the maximum profit occurs. That's the D star. Remember that we said these two are different. D hat and D star, okay? They're different things. Question F, determine the maximum profit per month. Okay, now you want to have the max profit. And G, question G, find the volumes or demands at which break-even occurs. Okay, that is, what is the range of profitable demand? So you're gonna have a range of D1 prime and D2 prime. Okay. To solve all these questions, this is the sheet you need with all the functions listed here. Okay, so you have CT, total cost, you have CV, total variable cost, you have P equals to A minus BD, you have your total revenue formula, which is AD minus BD squared. And you also know, like, when the D equals to D hat, you can reach your total revenue. You can reach the maximum total revenue, okay? And this is how you calculate the D hat. This is how you calculate the maximum total revenue. And also, if you want to calculate the profit, this is the function you're going to use, okay? And also, you know, when D equals to the D star, you can reach your maximum total profit, okay? So and also, if you want to calculate what is your maximum total profit, you just replace the D by D star in the total profit function. This is the function. So you replace D with D star. And you also know when D is between D1 prime and D2 prime, you will have your profit bigger than 0, which means you're earning you're earning, not losing money. Okay, you are making profit. And the way you calculate break-even points is this function. Actually, it's two functions, okay, merged together. All right, let's do it. Okay, so question A. If we can write P as A minus BD, so what is A and what is B? Right? If we given in the statement P is 100 minus 0.02 D. Okay, so compare these two formulas. You can easily find that A is 180, B is, don't include the negative sign, 0.02. That's it. Question B. What is CF? CF is given in the statement. It's $73,000. What is C lowercase v? It's also given. It's 83 per unit. Okay, question C. What is the maximum total revenue? Max TR. What is that? Based on the function formula, we know maximum total revenue is here, right? So it's A square over 4B. A square over 4B. What is A? A is 180 square over 4 times B, 0.02. Do the calculation by yourselves, and then you can get number. The value is 405,000. That's the maximum total revenue. And now, question D. Question D is, find the demand or volume at which the maximum total revenue occur. Okay, so that's gonna be D hat. D hat, the function for D hat is here. Okay, it's A over 2B. A is 180, B is 0.02. Okay, and if you calculate, it's 4500 unit, which means if you sell it at if you sell 4,500 units, you can reach your maximum total revenue. And question E is, what is the optimal demand, where you can have your total profit maximized? That's D star, okay? And D star, we have it here. It's A minus C lowercase v over 2B. So A minus C lowercase v over 2B. And A is 180, lowercase v, C lowercase v is 83. 2 times B is 0.02. Okay, and If you calculate this out, it's gonna be 2425 units. Okay, which means if you sell 2425 units, you can reach your maximum profit. And question F, what is your maximum profit? Okay, we said if you want to know the maximum profit, you're going to replace the D in that formula with D star. So what is the formula for total profit? It's here. So it is the max profit is minus B times D to the power of 2. But here we want to replace the D with D star. Okay, plus A minus C lowercase v times D. We replace D with D star, okay, because we want to know the profit maximized, minus CF. Okay, and we just substitute this with the values. So minus B is 0.02 times D star is 2425 square plus A is 180, C lowercase v is 83 times D star 2425 minus CF 73,000. Okay, just to calculate this, and then you can have the answer is 44,612.5. That is your maximum profit. Okay, and then question G is, what is the break-even points? What's the range where you can make your profit? Okay, so that range determined by the D1 prime and D2 prime. We say D1 prime is minus A minus C lowercase v plus a whole bunch of things, right? And what's that? It's C minus C lowercase v, sorry, A minus lowercase v square minus 4 times minus B, B is 0.02 times, oh sorry, we haven't used the value yet. So we're still doing the formula itself, okay? We want to rewrite the formula here. So it's 4 times minus B times minus CF, okay? And to the power of 1/2. So that's the square root of this whole bunch of things, okay? And the whole thing divided by 2 times minus B. Okay, now if we replace these letters by the values, it's gonna be minus 180 minus 83 plus 180 minus 83 square minus 4 times minus 0.02 times minus 73,000 to the power of 1/2 divided by 2 times minus 0.02. And if you calculate this out, the D1 prime is gonna be 932. Now let's move on to the D2 prime. Okay, let's do it here. D2 prime is, the formula tells you it's minus a c lowercase v subtract the whole thing, okay, in the bracket. What is the whole thing? It's a minus cv square minus 4 times 4b minus b times minus cf to the power of 1 over 2, okay? And divide this whole thing by 2 times minus b. And you're going to replace these letters by the values. A is 180, CV is 83, minus 180 minus 83 to the power of 2 minus 4 times minus 0.02 times minus 73,000, and the whole thing under the square root, okay, and divide it by 2 times minus 0.02, and calculate this. You can get 3,918 units. Here you still need the units. Okay, so let's do this, okay, to split this to space. So your break-even points, or what they asked, the range of profitable demand is gonna be a range from a lower value 932 to a higher value 3,918. So this is your profitable range, which means if your D belongs to this range, then you are making profit. Okay, so this example is very important, and I want you to practice by yourselves on this one. In the homework or final or quiz, we might or tests, we might have the similar questions with different values for A and B and C, F and CV, okay? But the questions are the same, the formulas are the same. So try to practice, especially for this break-even point, because the formula is very, very complicated. You need to practice how do you calculate it correctly, okay? And in case you couldn't get the right final results, which means your calculation and the progress has something wrong. In case you have that problem, please just let me know, and I can record something to just show you step by step, like how do you get from here to here. Okay, I can do that, but please practice by yourself first. Okay. All right. This is all for today. I know it's very heavy, so but this is very important. Okay, and everything is all connected. So we want to introduce all of them all together. And then in the next class, we're going to learn chapter 3. Okay, it's gonna be a new chapter. So before that, please go over these slides and then, try to figure out how do you use the formulas. All right, so